We want to get started by establishing exactly what statistics is, especially for those of you who've maybe never taken a stats course before, and establishing some terms and definitions that we're going to see used throughout this course. To start, we can break statistics down very generally into two steps. The first step is collecting data, and the second step is doing something with it. We'll talk throughout this course about different ways we can go about collecting data and the importance of collecting good data, but we're going to really be focused on that second step. Once we have data, what are the different things that we can do with it to make sense of it and help us answer questions? Another way we can think of statistics is as data with context. That is, we'll collect data or look at data someone else has collected, and we want to apply context and meaning to it rather than just having it be a string of numbers or a string of yes and no responses. We're going to provide some context to what those numbers tell us. We collect data on one or more variables, and our data can either come from a population or a sample. When we talk about a population, we're talking about the big, large group that encompasses everyone or everything we're looking at studying. So maybe that's all college students, all residents of Illinois, all Americans, everyone in the entire world. All cars manufactured by Ford, all trucks, regardless of manufacturers. A sample is some smaller group. So we can't ask everyone the same question. There's not enough time to go out and ask every person in the world the same question. We can't run every single car that's manufactured through the same tests. So we look at some smaller group of that population, and we refer to that as a sample. A result that we calculate from the population is referred to as a parameter, and I should write that a little bit more clearly. And a result that we calculate from a sample is referred to as a statistic. That's where the name of this discipline of statistics comes from, because that's primarily what we'll be dealing with. We'll talk about this more throughout the course of the semester, but it's hard to come up with population data. Generally, we're dealing with sample data to try to understand something about that larger population. In example 1, we want to look at applying some of these terms, some of these definitions, and we're told we want to know the proportion of people who would sustain head injuries after riding in a car from a particular manufacturer that crashed into a wall at a speed of 35 miles per hour. We randomly surveyed 66 cars from that manufacturer and crashed them at this speed with a crash test dummy inside. So in part A, the blank is whether or not a dummy suffered head injuries. That would be the variable that we're considering in this experiment. That's the outcome that can come out one of two different ways in this case. Either that dummy would have suffered a head injury, did suffer a head injury, or did not. The data is the sort of the result of that variable. When we look at that variable, we either say that yes, it sustained a head injury, or no, it did not. So in this case, our data would be yes and no responses. The population is all people who have or will experience this type of crash in this manufacturer's car. This is where we can start to see that idea that population data is really hard or impossible to collect. We can't take everyone who would ever own one of these cars, put them in one of those cars, and crash them into a wall. It's obviously not ethical. That would be a horrible thing to do. So we can't do that. So instead, what we study is the sample of the 66 cars that were crashed, and with crash test dummies inside instead of real people, obviously. So with our sample, we're not injuring any people. We are destroying some products that were manufactured, but we're going to look at this small sample, and that's going to help inform ideas about the population, all of those cars and all of those crashes. In part E, the parameter is the proportion of people who would have suffered head injuries as a result of a similar crash, and the statistic is the proportion of dummies, so the crash test dummies in these scenarios, who suffered a head injury. So the only data that we have is on the number of crash test dummies who suffered head injuries, but we're going to use that, or we would use that in the process of statistics, to understand the parameter, the proportion of people who over time, if they experience this accident, would suffer similar injuries.